Right. Okay, everybody. We have started. Now let's concentrate. Let's get to it. Make sure you are locked in. Let's enjoy the lesson. Let me change to my iPad. Yeah, you saw a sneak peek of what we're doing today. Look at this. Right, you see, in every single paper too, and in every single, we know that in every single paper 4, towards the end there's going to be that algebra. It may be 2, some papers it's even 3, where you'll get 6 marks and 5 marks, and to do the algebra question. Now I want to show you from the paper 2s, it's going to be there as well, and I want you to get all marks, guys. So what I'm going to be doing, I'm going to be doing several papers, and then I give you questions, okay? So I'm going to do some questions, some papers, explaining to you guys how to do it, explaining to all of you how I want you to do it, how you expected to do it, and then the next one is going to be yours. So make sure you're watching closely, okay? Watch closely, everybody. You can do this, right? Let's go. Those who are absent will be in trouble because everybody has to submit. Let's go. We'll go to, listen, look at this. Analyze this with me. All right, so here's what I want you to understand. If you look at most paper 2s, okay? When you look at most paper 2s, at the end of those papers, you're going to get a question which is 5 marks, 6 marks, 7 marks, sometimes even up to 8 marks. And it will be an algebra question. Look, when I say to be an algebra question, I mean that part of algebra that we have been talking about. Look at this, Laura and everybody. What we know is, Eric, what we know is our maths has 4 sections. And we know that if we put it, maths has 4 sections, the entire maths. So of course we are going to look at the question from the other sections. We'll analyze each section to see which question comes from section 1, what type of questions come from section 2, what type of questions come from section 3. So we know that section 1 of maths is number, okay? And we know that section 2 of maths is algebra. This we do every day, and this looks unnecessary, but it's so important. It's so important. And that's why I know you're going to do well. This is shape and space. We'll look at this unit. It's very important and very big as well. Then we know we have probability and statistics as well. So look at this. Okay, guys? Look at this. We are analyzing unit 2, which is algebra. Okay, this is actually the biggest unit when it comes to the marks that it will give you in the exam. We are going to do questions on functions. We are going to do questions on simple equations, okay, that they will ask you to solve. Some simple equations. We'll do questions on some inequalities, simple inequalities that they'll ask you to solve. We'll do questions on even powers, on laws of indices, application of laws of indices. I'll explain what I mean. We'll do questions on this. This is not the section that I want you to look out for, okay? Even those fractions, even expansion, fractions that have a letter of the alphabet, or expansion, or factorization. Listen, everybody, listen to this. It's very easy to know that this is an algebra topic. It's very easy because what we know is that any algebra topic has letters of the alphabet in maths. So if we look at this last question here and we start to see x and x and x, we see all these x. This is algebra. This is algebra. This is clearly algebra, right? So yes, we know that this is algebra, but that's not the one I'm talking about. We're still going to do it, okay? I'm going to do a lot of questions with you, including this part. We are not ignoring this. It's also algebra because we are seeing letters of the alphabet. So guys, everybody, if anybody comes and says, what is algebra? What is this unit about? You say it will be just letters of the alphabet. It has a lot of things, okay, that you'll be doing with those letters of the alphabet. But at the end of the day, you need to find what the letter represents. Find the value of x or do something, right? So this is all important. I know algebra, all this stuff, but there is a certain part. Give me 1 second, give me 1 second. There's a certain part that we are concentrated on, that we are concentrating on, which is, I need you to be able to get those marks in the exam, okay? It is going to be this area. A question like this one. This, I'm going to explain to you. Give me 1 second, okay? Give me 1 second. Okay. Thank you for your patience. Back. So let me say, we have a certain part of algebra that we know they're going to bring at the end. We want to analyze that part, and we want to be able to solve. We are not losing a mark in the exam. We are prepared. Let's get prepared, okay? Right. So here's the first one. Let me already give you a heads up. So, and give you the information that I need you to know. Thank you. Right. So let me give you the heads up and the information that I want you to know. I'm going back here. The things that we are going to make sure we are good at are these. It's going to be algebra, right? And it's going to be either differentiation, okay? In the paper 2 especially, differentiation, and when they say differentiation, they usually will be wanting something related to the stationary point. To the stationary point. We saw that yesterday they wanted equation of the tangent. When we looked at which was still differentiation, which I still told you from that paper, okay? And I want you to go back and check again. That is why we are recording. I'm recording so that you can be able to refer back and polish up and make yourself ready. You know, how easy is it when you work around what is coming in the exam and you know before the exam comes? It's like you have the marking key. So look at it. Keep looking at these videos, and we are preparing. We're trying our best, okay, to be as ready as we can. So what we are looking at is what comes in this paper 2 as the last question usually, or one of the last questions, and it has a lot of marks, and it's from algebra. I have showed you that it's from algebra. I've told you that algebra is part of the 4 sections of maths, and I'm now showing you what they will bring you. It's this, or it is going to be coordinate geometry. When we say coordinate geometry, something to do with the midpoint or the length of the line or whatever. So we're going to be prepared. We are going to be prepared. Do you hear me? Students, are you hearing me? You also have something that they can bring. We'll see. Okay, we'll see when we get through. But it's usually differentiation of all this. So let's see here. We'll look at the other things, but let's see here. Right. We know that this word, stationary point, and the word equation of tangent, they are words that are there when you are doing the topic of differentiation, which is part of Unit 2. Differentiation, right? We have differentiation. We looked at simultaneous equations. I'll look at more simultaneous equations. And this, we have a lot of work, especially, I'll try to make time tomorrow. Last time I couldn't, but tomorrow I will. Differentiation, look at this. The word stationary point. This word is the word, this is the one word which I want no one here to fear. Let's work with this word stationary point, okay? I want to do things one by one and give you questions. So this is the February, March 2025. I'm going to give you yours. Okay, get ready. We are just going to be walking through these papers and analyzing. I'm going to give you yours, which is going to say something similar to this. So better listen closely now. Listen closely. Right. The word stationary point. Are you listening? It is, if you are putting it on a graph, okay, you'll be having a graph which curves. The graph will be curving in some way. It can curve once, it can curve twice. This one here curves twice because it's an x cubed. So either it curves like this, or it goes down, then it goes up, then it comes like that. But it curves twice. It curves twice. Are we together? First curve, second curve. All right, so it may curve once like this only, or like this if it is for x squared. For x squared, you get either this one or this one. For x cubed, if the highest power is cubed for y equal to x cubed, then you're going to get either this one or this one for x cubed. All right, so you have seen the types of graphs you're going to get. So now they will want you to find stationary points. Stationary points are these ones here. These are stationary points. And what you are seeing is, if the graph is x cubed, there are 2 of them. There are 2 stationary points. In other words, it is going to curve twice. So when you're talking about a stationary point, you're talking about a peak or a trough. You're talking about the highest or the lowest point. You need to find them. And they are easy to find. When I see the word stationary point, here if it's an x squared, it will only be 1, either on 1 or on 2. But you can see for x cubed, there are 2 on 1, there are 2 on 2. For x squared, there is 1 on the first graph, there is 1 on this one. So anyway, what I want you to know is that when they ask you to find them, either they can give you a graph and they'll say, find coordinates of P and Q. They say this is P, this is Q. Then they ask you to find their coordinates. Come on now. They are just saying find the stationary points. They're saying find the stationary points, and they are doing it through a graph. That's the same thing. Or they may not give us any graph like this question, and they'll say the word. Once you give us the word stationary point, we know what to do. We know what you're looking for. You're looking for the highest point and the lowest point on the curve, on the graph. And it's a differentiation thing. How do you do it? 2 steps. 1, you first find dy dx. Okay? Then 2, you let dy dx equal to 0. Because at stationary points, let me say, listen, okay, maybe I don't want to over-explain, but at stationary point, there is one special thing. It's the only time your gradient is flat. It's the only time that you have a flat line. Exactly at the stationary point. It will become flat before it will start to curve down again. So it's flat, yes. So the graph is flat, yes. So at the stationary point, it's the only point where dy dx is 0, yes. What does it mean to say dy dx is 0? It means gradient. Slope is 0. It's flat. If the line is a flat line, then that means dy dx is 0. So, my students, listen. Stationary point, if I don't see this stage, then I will be so disappointed. No one is going to tell you to do it. I've told you now. Make dy dx 0. Then solve. You will have the stationary point. So say, why is it that they'll give us 5 marks for something like that? Just to let dy dx 0. Yes, it's because solving is not so easy. You may have to use quadratic formula to solve. Because you'll be now having an x squared, which you'll be needing to solve. And when you solve it, you'll be needing to look for the other point and stuff. So it may take a bit of time. But it will be you making dy dx equal to 0. You are not letting me down. No. Come on. It's so easy. So this, I'm going to show you paper after paper after paper after paper, where they'll be asking about stationary point, just changing words, changing things, changing words. But this algebra question is coming. Either they'll ask us for this, or they'll ask for midpoints and whatever, or they'll ask for both. I'll show you papers where they do both. Okay, so in this one it was number 22 out of 25, or out of 23. Oh, okay. So it's actually it's usually one of the last questions, right? And look at this. They even brought in number 21, the other question that I've been talking about, where they'll say find the perpendicular bisector or midpoint or whatever of the equation of the line, blah blah blah, and they give another 5. We are expecting it. That's why we are not losing these marks. Imagine you go in an exam and nobody has told you this. Can you just imagine this? Then you walk in there and you see this big 5-mark question, and nobody has told you that these type of questions are coming all the time. Okay, because they actually come all the time. Imagine you go there not knowing, you don't know how to do this, and you lose 10 marks for paper 2. That's not an A-star student, right? You will not get an A-star. Forget. Losing 10 marks. You can't. That's why you can't afford. Laura, Catlo, Hope, you can't lose this 10 marks. let's do the stationary point. We'll do that other one. We know it always comes. We already know. I've already showed you. I've already told you. There are many, many papers that I have for you. Many. I just don't know if we'll be able to go through all of them. But there are many, many, many. Okay? Are you hearing me? Are you ready? Students? Thank you. Let's see. Let's continue. Wait. Something is wrong here. Give me 1 second. Right. Now let's start. Let's start. I've prepared you, okay? Now let's start. So what we know, let's quickly go through the questions, and I'm going to give you, you do yours, and you have to submit. So look closely and do these questions first. Here we see the word stationary point. So before we do anything, the moment we see the word stationary point, we are going to write y is equal to x cubed. We know that is differentiation. So you write y is equal to x cubed plus x squared minus x. First step, find dy dx. Okay, for stationary point, we know that when it's stationary point, the first step, we have the y, we find dy dx, which is the derivative. Then we will let that answer, that dy dx, be equal to 0 and solve. So this is the curve. Y is equal to x cubed plus x squared minus x. So now we're going to say, what is the dy dx? We now have to find dy dx. Let's do it. Drop the power, reduce it by 1. So you drop the power 3, you reduce it by 1, x squared. Plus, here, drop the power 2, reduce it by 1, x. Then differentiate this minus 1. Okay, derivative of x is just 1, minus 1. We have found the dy dx. Drop the power, reduce it by 1. Drop the power, reduce it. We dropped this power, 3. It came down here. We reduced it by 1. It becomes x to the 2. Then we dropped the 2. We reduced it by 1. Don't forget. That's how you find dy dx. It becomes x to the 1. Then derivative of x is just a 1. But if it was a 2x, it would be a derivative of 2x is 2. 3x is 3. Negative 5x is negative 5. 7x is 7. But derivative of just an x is 1. So this is what it is. Don't forget. Don't let me down. Now we have found our dy dx. Well done. I'm happy. Next. For stationary points. This is you now. Okay, you have seen that word, so you're not thinking about anything. Don't change my order. Don't you change my order. I want you to say, for stationary points, okay, you say, let dy dx equal to 0. For stationary points, let dy dx equal to 0. What is your dy dx? This one. So you're going to say 3x squared plus 2x minus 1 is equal to 0. The dy dx. We've made it equal to 0. Now we have a quadratic equation to solve. But guess what? We don't fear these ones. We don't fear quadratic equations. We don't fear quadratic equations. What is it? What makes it quadratic? The highest power is 2. We need to solve. So we find x. Come on. Why are you stopping? Keep going. Find x. This is a quadratic equation. We know that at the top there, they would have given you the quadratic formula. Look, you go all the way to the top in case you don't know it. The quadratic formula here. It's there at the top of the paper. In front here, at the front of your paper. Here. Here. This one is the quadratic formula. And they'll tell you it works for ax squared plus bx plus c. So they even teach you how to use it. You need to know how to use this one. So it's not only about just seeing it. You need to know how to use it and the steps to do here. So let's go write it because we know it. Let's go write it at the bottom. And let's use it quickly. and now get the solution. We are not losing marks for this one. We are preparing, no matter how hard it takes, no matter how long it takes, no matter how hard it is. So what you're going to do, you will now say, all right, this is my thing. You say now, okay? You say let A. We know that the quadratic formula, if you want, you can write it to say x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Quadratic formula works in every situation. It can solve any type. So you have write it, you've copied it and you write it down. We know that it works when you have what? It works for our ax squared plus bx plus c. So we need to know who is a, who is b, who is c. A is the number before x squared, which you need to write to say 3. B is the number before x, which here is 2. C is the number which is alone. B is the number before. Somebody, last time when we were doing this one, somebody put B as he took 2 with the x. Don't put the x in my quadratic formula. There'll be a big problem there. Leave the x. Take the numbers. The numbers. 3, 2, and c is -1. So we have it like this. Now we have to solve for it. So we would be saying, oh, okay. First thing we get is this one, which is inside the square root. You now say b squared minus 4ac. This is going to be equal. So you know your a, you know your b, you know your c. You have put the quadratic formula. The first thing you find is b squared minus 4ac, which is the stuff inside the square root there. What is it? What is b? It's 2. So it's 2 squared minus, you open a big bracket. You say 4 times a, which is 3, times c, which is -1. So this 4ac, you put it inside a bracket like this. Don't let me down, students. Don't let me down, please. This becomes equal to 2 squared is 4 minus, you open this bracket, 4 times 3, that's 12. Times -1, you put it in your calculator, okay? This one you won't have a calculator. So 4 times 3, that's 12. Times -1, that's -12. That's -12. So this is actually 4 plus 12, which is 16. See, they're giving you easy ones. Now you know, so you can now rewrite it to say, okay, x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a, which means x is equal to minus of b. You know what b is? B is 2. So it's minus of 2 plus or minus the square root of b squared minus 4ac. You got the answer here to be 16. So minus the square root of 16. Oh, do these steps. Do these steps, please. O over 2a, which is 2 by 3. X will be equal to minus 2 plus or minus square root of 16 is 4. So plus or minus 4 all over 6, which means you say x is equal to minus 2 plus 4 over 6, or you have x be equal to minus 2 minus 4 over 6, which is going to be x is equal to minus 2 plus 4 is like 4 minus 2. You get a 2 over 6, which means your x will be 2 into 2, 1 into 6, 3, to be 1/3. Then here you get another x being equal to minus 2 minus 4, that's minus 6, all over 6, which means x will be equal to minus of 6 over 6, which is 1. Here is the second x. So we have them. Now what we need is the y's. We have the x values, now we need the y values because we want the coordinates of the stationary point. You see, it's easy. It came from you finding dy dx and then letting it equal to 0. Your dy dx was this one, this answer here. This answer here. You made it equal to 0 here. Okay? And you solved. Well done! That's what you do all the time. Whether they tell you the answer, they don't tell you the answer, whatever. Don't think about it. There's no other way. Find dy dx immediately. Whether you know the the numbers or what, I actually don't care. You have to find the gradient and you make it equal to 0, because the stationary point is the highest or the lowest point, and what we know about there is the line is flat. The slope is flat. The gradient is 0. So anyway, they gave us this one here for x, where x was 1/3. So where x was 1/3, this solution, they already gave us the answer because they already gave us the y. Now we want the other one, which means we are now using this one when x is -1. We need to find the y. Okay, so here we will put -1. Now we need to find the y value. So how do you find the y value? There's only one way. You put back in the original equation. Although we were no longer using it, we have to use it again to find y. So you say y is equal to x cubed plus x squared minus x. This is the original equation. Then you feed this value of x. So you say let x be equal to -1. So y will be equal to -1 cubed plus -1 squared minus -1. Okay, minus x, which is minus of -1. Which means y is -1 all cubed is -1. Plus -1 all squared is a 1. Okay, when you square things, they become positive. Then minus 1 is another +1. So this anyway becomes -1 plus 1, it becomes 0. Then plus 1, it becomes 1. So y will be 1. So you put your 1, and you have 5 marks. You have 5 marks. Is there anyone with a question here? Is there anyone with a question on this one where you are finding the stationary point? Anyone with a question where you are finding the stationary point? Anyone with a question? Right. Let me open this one that I want you to do. Solve this question. This is your first question. Here. Okay? If they give you like this and they say differentiate this one. If they give you this one to say differentiate, okay? There are many ways to do it. If you want, you can say to differentiate it, you can say let y be equal to x cubed minus 3x squared plus 1. Okay, they want you to differentiate it. Now find dy dx. Find it. Drop the power, reduce it by 1. Okay, drop the power, reduce it by 1. I'll help you here. Let's differentiate. We drop the power. 3 goes down, we reduce it by 1, it becomes x squared. You can't. You cannot see my screen. Can you see it now? Let me fix. Akian, check the YouTube channel. Check the YouTube channel. You see the thing we're doing. Okay. Right. So you let y be equal to it. Then you find the dy dx, which is drop the power. You drop down the 3, reduce it by 1. Minus, drop this power of 2. You drop it down. It will multiply 3. 2 times 3, you will get 6. Because it drops down to multiply. Then you reduce it by 1. It becomes x to the 1, which is nothing. Derivative of a number is nothing. So it goes. So you can say this is 3x squared minus 6x. Now here they say the word turning point. Once you see the word turning point or stationary point, you know what to do. You find dy dx and you make it 0. So you have your y here. They've said the word turning point or stationary point. It's the same thing. You find dy dx, which you see that it's exactly this one. You've already found it here. It doesn't matter. You can find it again. Find dy dx and let it be equal to 0. So you have it as y is equal to x cubed minus 3x squared plus 1. They've said the word stationary point. So please find the dy dx and let it be equal to 0 and solve. Maybe let me solve this one because it's the last one and it's an easier one. So you say here dy dx is equal to, drop the power 3, reduce it by 1, x squared. Okay, let me reduce the thickness. Then minus, here drop the power, 2 times 3, 6, x to the 1, because it was x to the 2, now it's x to the 1. Then derivative of 1 is nothing. Then I'll say 4 turning points, because they are asking for turning points. I know there's only one way. Let dy dx equal to 0. If I ever forget this stage, I've thrown away everything, because that's the main stage. So let dy dx equal to 0. So you will now say, what is your dy dx? 3x squared minus 6x is equal to 0. That's your dy dx. Now, this is an x squared. Yeah? This is a quadratic one. If there are two things like this, it's easy. You just solve by factorization. You know that one of the ways of solving quadratic things is factorization. We don't have to use the quadratic formula for this, because you say factorization, yes. Of this, yes. How do you factorize this? You pull out the number that is common. You see there are 3. You pull out the number that's common. That's 3. Then you pull out the letter that's common between here and here. The lower power. Because there's x here, there's x here. Which power is lower here? Just the x. So you pull out the x. You will now say 3 into 3, 1. X into x squared is an x. Okay? You had 2. You are removing 1. You remain with 1x. Then you say minus 6 divided by 3 is 2. Then this x divided by dx is 1. It's nothing. So this is like this, is equal to 0. Which means you say 3x is equal to 0, or x minus 2 is equal to 0. Which means you say x is equal to 0 over 3, or x is equal to 0, or here you say x is equal to 2. So we now know our x values, 0 and 2. Now what's left is the y. So we will now say, okay, to find the y values, you go back to the original equation. How do you find y values? You go back to the original equation. Before you did all these dy dx, the original y, you start putting your answers in there. So here, what are the answers? x0. So you can say, let x equal to 0. You get y be equal to 0 cubed minus 3 by 0 squared plus 1. Anything where there is 0, it's going to be a 0. Here it's going to be a 0 plus 1. So you just get y equal to 1. So y here will be 1. Then you can write again, y is x cubed minus 3x squared plus 1. You now say, let x equal to the other one here, which is 2. You now have y be equal to 2 cubed minus 3 by 2 squared plus 1, which is y is 8 minus 3 by 2 squared is 4, then plus 1, which is 8 minus 12, that's a negative 4, plus 1, that's a negative 3. You now you can start by trying with your calculator. then you can do without. Yes, Eric, I see your hand is up. Yes, I see your hands are up. Tell me. What is the question? Yes. Okay. Which stage? Finding the y value. Okay. Did you all see that we took this original one back when we were finding the y value? Then we started to feed into it the answers that we got for x. Because we got answers for x, those answers, we use them to find y. So you rewrite the y, then you say let x be 0. In other words, wherever there is x, we are putting 0. So here it would be 0 cubed because it was x cubed. Then 3 by x squared is 3 by 0 squared. Then plus 1. 0 squared is what? Is 0. Times 3 is 0. When you're multiplying by 0, so this is still a 0 here. This is a 0 cubed, which is still a 0. So it's 0 minus 0, which is 0, plus 1, which is 1. Do you understand now? Do you understand? Okay. Then you bring it back again, the y, because we want to find the other y. Then you feed in the answer for x. X is 2 here. You now come and say, let x be 2. Wherever there is x, we are now putting 2. So it's x cubed. It becomes 2 cubed. Minus 3 by x squared minus 3 by 2 squared plus 1. X cubed, 2 cubed is 8. Minus 3 by whatever, which is 3 by 4, then plus 1. 8 minus 12 plus 1, you get a negative 3. That's the answer we got. Then you get your 4 marks. Have you seen this? It's now your turn, right, guys? Are you ready to do yours? Guys? Okay. Here's yours. The problem is there's always like a small difference in each one. I want to pick one which is similar to the ones I've done. Let me choose one. Let me choose one. Give me 1 minute to choose one. If I don't really find one which I want, I'll just have to give you the one I have already. Although it's a little bit different, but I think you'll be fine. Let me give you this one. Okay. Number 21. Right. They said differentiate this one. And then they said find the coordinates of P and Q. If I come here, I'll show you. P is this one. Q is this one. So anyone with two eyes can see that these are stationary points. They want the coordinates of stationary point. What's this graph? It's y is 3x minus x cubed. So you say here, y. Find the coordinates of the stationary points on a graph. Y is 3x minus x cubed. This is the graph. So for this graph here, let me see if you'll be able to do it. For this graph here, you need to find the stationary points. Can you do it, please? That's your question 1. Start, everybody. Start. Solve it, everybody. Have you done it? Tell me, is it doable? Are you managing? It's doable. Those who are stuck, raise your hands. Okay, so continue. Okay. At which stage? Which stage is tricky? The equation? Solving the equation? Raise your hands if you are not stuck. Okay, let me let you try that. That's good. Continue. Let's see. Get me the answers. I'll explain something after this, okay? Yes, so continue. Continue, guys. Okay, let me give you one more and then it's enough. Here's one more. Sorry that the ones that I gave you, I want to apologize, guys. The ones that I gave you, x squared is always negative and it's at the end. But this one is a little bit easier. I think you can be able to do it. Y is 7 minus x squared. You can differentiate this, okay? Don't be disheartened, my students. Dy dx, here 7 becomes nothing. It's a number. Negative 2x is negative 2. The x flies away. Then here you drop the power, so it becomes minus 2. You reduce it by 1. It becomes x to the 1. So it becomes minus 2x. So this is what you have. And you know that they want turning point, so you let this be equal to 0, which is so easy, okay? Because if you say for stationary point, let's say I have minus 5 minus 5x as my dy dx. Let's just say I have it. I know that I'm going to let it be 0. I'll write for turning point, blah, blah, blah. Let dy dx equal to 0. I'm showing you so that you can know what to do. It'll be minus 5 minus 5x is equal to 0. This is the easiest thing. It's not an x squared, it's just an x. So you can find it. You take it to the other side. It becomes minus 5 is equal to 5x. Okay, because if it goes there, it will become a 5x. Now, obviously, you take this 5 to the other side to divide. You have minus 5 over 5 is equal to x, which is minus of 5 over 5 is 1 is equal to x. So you know what your x is? It's minus 1. Now you need to find the y. You go and you put it again in here, the minus 1, then you find your y, and you are done. So do the same thing here. Do the same thing here, let's see, and get your 4 marks. Do the same thing here and get your 4 marks. I'm counting on you guys. Do the same thing here and get your 4 marks, let's see. To get your x and to get your y. Do the same thing. All right. After you do this one, there is one more word that I want to train you, and I'll give you one question to try to see how you are, and then it'll be done. Okay, which comes a lot. It comes a lot. There's one more word that I want to train you, and then we'll see how it goes. I'm sure you are done with this one. You can finish it up, right? You can finish it up. You have already started. You need to find X and Y, and you are done. Okay, you send me my picture. There's one more word that I want to train you, and let me choose the question that I want to show you. It's called perpendicular bisector. I want to train you that one more word. It comes a lot of times. So I'm going to do one paper, then I'll give you to do a question from another one. So let me choose. We'll do more of, let me go to the question. We'll do more of the simultaneous equations tomorrow in the lesson. So make sure you're ready for that. I have reserved a lot of them that I want to show you. So we'll be analyzing them together in tomorrow's lesson during the day. Right. Is it this one? Is it a full paper? Oh, this is not a full paper. I want question 22 of 2024, paper 22. Wait. This is the question we're going to do. We'll do the solutions to the one I already gave you tomorrow, to those two questions, but you send them to me, I go through them, then we do their solutions. Right. Let's go to the question. We are analyzing this word perpendicular bisector. So I'm going to give you a question and I'll need you to do it. This is the algebra question. Okay? They are bringing it. We are not surprised. We know that either they'll give us a simultaneous equation question, or they'll give us this, or they'll give us the other thing. I've been just showing you the differentiation. So look at this now. This is perpendicular bisector. We are analyzing this word. I'm building you up. This is section 2. We know we have 4 sections. For our maths, we know we have 4 sections. This is the middle one, algebra. And we are studying this word, perpendicular bisector. I'm going to give you also a question soon after this one for you to now try out. So look at the steps that I want you to do. Let me give you some. I want to explain to you what you're going to do. Okay? I'm not going to explain the whole thing. It's too many things. I'll just explain to you what you do here. The word bisector, it means something passes through the midpoint. So if you're doing a bisector, it means something passes through the midpoint, which means you'll be saying you're going to use this formula, x1 plus x2 over 2. Then you use y1 plus y2 over 2. So I've given you the formula for midpoint. Okay, I'll summarize all of them for you, but I want you to do one thing at a time. So the word bisector, it means we want to see you use this. If you have a line, let's say you have a line called AB, then they say there is a line which is a bisector. It means that line passes through the midpoint. Any bisector cuts right at the middle, and it cuts at 90 degrees. So it's going to cut right at the middle, like this, passes through the midpoint, and it will be at 90 degrees. So this is the perpendicular. This is what we call a perpendicular bisector. So the word bisector means it passes through the midpoint M. So we are going to need to find it. It passes through there. Then at 90 degrees, which means we are going to use the fact that it's perpendicular. What will happen when you use the word perpendicular? For perpendicular, if M1 is equal to, let's say, 2 over 3, the first gradient, then perpendicular gradient, which is perpendicular M2, will be, you flip 3 over 2, then you change the sign, negative. So this is going to be for our negative. We'll flip and change signs. So here we are going to come, so that's what we're going to do also. We are going to use these two and we are fine. We are going to find a new M by flipping, okay? We are going to flip and change signs to get a new M. Then we are going to use this idea as well, and we are done, okay? We are going to know that it passes through midpoint. So we are going to feed midpoint, okay? If something passes through anything, you feed that to get C. C is going to be an important one. M, we are going to get it this way by flipping. C, we are going to get it by midpoint, throwing midpoint. Let's go and do it. Let's see. We are so okay. So it's so easy, sir. Yeah, that's how easy it is. Yes. Let's quickly do it. So here we have A. They'll give you these 2 points. These 2 points, once you get them in and you see the word perpendicular bisector, here's what I want you to do. Sorry. You go to the first point, you call it point 1, then you go to the other one. Okay, so this is point 1. Then the other one is obviously now point 2. We need point 1 and we need point 2. At point 1, the x is going to be x1 and the y is y1. At point 2, the x is x2 and the y is y2. So you need point 1 and point 2. Everything at 1 is x1, y1. At 2, it's x2, y2. So we have point 1, we have point 2. We have the 2 points. Always number your points. These points are given to you so that you number them and you use them. So I've numbered them, now I can use them. Thank you. So what you're going to do, you're going to say, okay, I need to find perpendicular bisector, right? So this one. This is the one I need to find. Y is mx plus c. It's a line. So that means it's going to be y is mx plus c. I need m, I need c. So I need to find this too, and I'm done. How do I find m? I first find, you say m1 is equal to y2 minus y1 over x2 minus x1. Everybody must know the formula for gradients here. We need you to know it. y2 minus y1 over x2 minus x1. What are you finding? The first gradient. But we know that we are going to then find the second one by flipping and changing signs, because we want perpendicular. So to find perpendicular, we first need m1, and then we will flip it and change signs. So we first need m1. M1, we find it nicely, okay? We calculate it using the formula, using the 2 points we have. So m1, what is the m1? It is going to be, what is our y2? You go to point number 2, you take the y, 39, minus what is y1? You go to point 1, you take the y, 9, over what is x2? You go to point 2, you take its x, 23, minus x1, you go to 1 and minus 17, which is going to be 39 minus 9, that's 30, over this 6, which is 5. So m1 is 5. Which means to now get the m2, it is, you flip m1. m1 is 5 right now. When you flip it, it becomes 1 over 5. Okay? Because 5 is, when you flip a whole number, it becomes 1 over. Then you change signs. Okay? So it's negative. This is the perpendicular. You can write to say perpendicular m2, because they said perpendicular bisector. So we first work with the word perpendicular. Word perpendicular, we said you flip m1. So you need to find m1, then you flip it, and you change signs. Here it was positive, here it will now be negative. If it was negative, it will now be positive. So we have m2. So we can now already write to say, y is equal to m2x plus c, which means y is equal to negative 1 over 5x plus c, because we already have the m. That's why we found it, so that we can put it. Now we are left with one thing, which is the c. We need to find the c. And we're done. Now to find the c, what did I say? I said first find the midpoint. Midpoint m is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. Don't forget these formulas. These two formulas, you're going to need them for gradient and for midpoint. So let's find the midpoint. x1, we go to point 1 and we take the x, 17, plus x2, we go to point 2, we take the x, 23. Then you divide by 2, comma, y1, you go to point 1, you take the y, it is 9, plus y2, you go to y, you take the, it's 39. Then you divide by 2. Which is here 40 over 2, comma, here it is 48 over 2, which is 20, comma 24, something like this. So you have 20 and 24. This is the point you are going to feed in here to find c, and you're done. So you're going to write to say y is equal to negative 1 over 5x plus c. Now you need to just find the c. The reason you did midpoint is you need to find c. So you're going to say this is your new y, this is your new x from the midpoint, the answers you get to midpoint. So you say let y be the new y, 24, and x be the new x, 20. So where there is y, we are putting 24 is equal to negative 1 over 5 by x, which is by 20, plus c, which means we are going to say 24 is equal to negative 1 over 5. It's like negative 5 into 20, that's 4. Okay, you say 5 into 5, 1 into 20, that's 4. 4 times 1 is 4, so 4 plus c. You take to the other side, 24 plus 4 is c. c is 28. So now you can already write to say y is negative 1 over 5x plus 28. You can now write negative 1 over 5x plus 28. You are done. Have you seen this word, perpendicular bisector? Have you seen it, students? Have you seen this word, perpendicular bisector? So we have this. Don't forget. It's so easy. Please. These are the formulas you need to know. The ones I've put in boxes. Thank you. These formulas I've put in boxes. Please make sure you know them. We're going to use them and you'll be fine. Should I give you one? Okay, I'll give you one as your assignment. You do it overnight and submit it to me tomorrow. I'll dismiss you early today and we'll meet twice tomorrow, sunset and in the evening. I'll confirm the times, but sunset and in the evening tomorrow is guaranteed. I'll make sure it happens. Thank you so much, everybody. I'll give you the assignment on perpendicular bisectors. I'll gather about 2 or 3 questions, then I'll send them to you. Get them done, do the work, send it back to me, and I mark. Remember, you don't do it now whilst you still know. Okay? And you can go to the YouTube, you search Mr. Clarify, okay? You search Mr. Clarify, you see Mr. Clarify tutorials, then you click on the channel, then you go where it says live videos. Are we together? You search Mr. Clarify, then you go to live videos, you see the stuff. Are we together? I'll send you the link in the group. Okay, students? Well done, everybody. You are dismissed. Goodbye.